Hey everyone, it's Gummy again. For this video, I'm going to talk a little bit about where the project began, and then delve into specifics about how the software has been programmed. So, looking back, I first started working with private servers back in 2010, when I was still studying at university. Now, the Burning Crusade project originally began in 2011 when me and a couple other guys started figuring out what needed to be done if we wanted to make our own program. After my first project, which was completely based on mangoes, we wanted to see if making our own software was feasible. Staying with mangoes wasn't something I wanted to do, which, for me, is why I decided to move on something that I felt could be bigger and better. Things kind of went slow at first for the project. We weren't working on it every day. For me personally, I was mostly still tinkering with mangoes and seeing what was good about their design and what wasn't, but my work towards vanilla servers had already convinced me that patching it up wasn't going to work. Something to note, I don't think that C Mangos, or Continued Mangos as it's called, was around yet when things first got underway. I could be wrong on that, but I think around that time frame there was just regular mangoes. But anyway, for our software there were some things that needed to be similar or the same. Old Azeroth wasn't around anymore, so we were going to have to import much of their database as a starting point. Recast Navigation is the only free pathfinding library I know of, or it's the best one around anyway, so we use that. Developing a different Warden module kind of went beyond the scope of what I felt I could do. And most notably, there aren't exactly a ton of packet logs floating around specific to TBC, so I've had to rely on their data, which is right most of the time, but not always. Early on, the overarching goal for the project was to make it possible to create content without coding specifically towards any one thing. But before I could start tackling the gameplay, we were going to need a much more modern framework. So the first area I decided to start in was the ACE library, which was actually still being used at the time by Mangoes. There were also a lot of other open source classes written in older versions of C++, like the database classes, which actually I modeled my work after, but I wanted to make a class using the new C11. But anyway, ACE was in charge of a lot of things, most notably communication and threading. Threading wasn't clunky anymore in C11, and I do everything with Windows anyway, so loading an ini instead of a config wasn't really a big deal. Obviously making singletons doesn't need something as fat as ACE. And about a year later, C Mangos ended up using Boost, but I had actually already developed my own classes for communication back in university, programming directly with WinSock, and I was really excited to put it through the ringer. Looking back though, the project as a whole actually took a lot longer to write out than I originally expected or intended, because when you have all the ideas in your head, it feels like it's going to take no time at all. And very early on, the mistake I made was trying to replace what Mangoes had with what I had, and after a while I decided to just start empty while I worked out the basics for connecting, authenticating. That turned out to be the right idea, and like I said early on, I still had it in my head to find a middle ground between using good parts of Mangoes, so that what I was doing was, I was making different classes for sessions and sockets, and then I had my own authentication program, and I was kind of building my own wrapper, so to speak, with the intent of filling it with Mangoes gameplay. And like I said, that was the mistake that I was making, and that cost me a little bit of time, and I had to walk back a little bit, but it wasn't a total loss because really I was deepening my understanding of the game as I went along. So I suppose in the back of my mind I kind of half expected that to be a mistake, which is why I tried to keep my code and their code from becoming too intertwined, so to speak. And when I started looking over the gameplay code, that's when I really started knocking down doors. So to back up a little bit, people have constantly asked us if we started with a brand new project on day one, and then started coding from there with a blind eye to Mangoes. I learned a lot from Mangoes during university, and it's a big game. So I'd have to say that we kind of used it as a guiding light that outlined everything that needed to be done. I went through every file, structure, and class, and then began writing them differently. In hindsight, I realized that this isn't an ideal way to develop software, but then again, developing a server as a way to copy a game isn't an ideal way to program a game in the first place. One of the things I wanted to move away from was using client data as a supplement for server data. It's not that Mangoes wasn't aware that this was a problem, it's more so that their hands were kind of tied. Mangoes, as an open source project, wouldn't be allowed to distribute data or modified data that came from the game. That's why they have their users extract files on their end. But the point is that there's only so much the client knows. like spell templates for example, notably the biggest piece of the puzzle. The client doesn't know if, say, a spell is a buff or a debuff. The server is the one that tells it that information. Now, in order to decide if something is a buff or a debuff, what Mangos does is it checks each of the 3 possible effects a spell can have, and then it tries to deduce an answer to the question at hand. For example, if a spell targets an enemy, they say it's a debuff. But if the spell heals instead of damaging, they'll then say, no wait, it's a buff. But sometimes a spell might not do anything. It might just be a visual indicator. And then that's where you see giant switch cases in their code. So a better solution is to just manually define these. We obviously populated the initial data with a similar process of a deduction, but instead of addressing corner cases with switch cases, we edit a variable. Even more basic things aren't always well defined by client data, like spells that require you to be behind your target, especially creature spells like that. That's not exactly defined on the client. The server is the one that makes that check. The radius for a frontal cone, like a cleave or something, that isn't defined at the client either. And the list kind of goes on like that. When I last saw it, Mangos had a number of odd issues with groups, group loot, notably the looking for group manager that's very unique to TBC. I'm scrolling through the related files so that you can see some of the code, but the short summary is that I felt like it'd be easier to just make new classes for this stuff than it would be to investigate the old ones. Plus I like coding, so there is that. So right now I'm looking at my class for game object pooling. So what it tries to do is manage what objects are and are not allowed to spawn within a specified zone. For example, we want to manage the number of mining nodes that can exist at any given time in a given zone, but we also want to prevent clumping when possible. At program startup, the pool handler is fed information on every game object the server knows about. It's given the 32-bit UID, the entry, the zone, and where it belongs in the world. The container that holds everything is an unordered map of unordered maps. We look to see if this zone pools anything, then we check if that entry belongs in a pool, and if we found what we're looking for, we return a pointer to the pool. Something to note is that this container doesn't actually change during runtime, so this pointer will stay valid even though we're only going to use it for a short period of time. And then we add it to the list of known spawns where we remember its position in the world. And the reason we want to remember that information is so that later we can avoid picking objects to spawn that are near other ones. And looking in from the outside, the general idea during runtime is quite simple. We tell the pool handler when an object despawns, and the pool handler tells objects that want to respawn whether or not they're allowed to. In one of my previews, what I outlined for the AI is the inheritance that's been set up. What I wanted was a way to have different AI types that also shared the ability to issue commands specific to that mob. Mangos called it Event AI. And for them, that became the meat of almost every creature in the game. But for us, the meat of every creature are these child classes which have the ability to call commands, but don't necessarily need to in order to get the job done. This block of code here is what makes the caster kite a little bit when he frost novas me, and since it's the same code for any caster, I can rely on it always working, which isn't necessarily the case in Mangos, depending on the series of commands made up for that specific mob. But I've done a number of videos on the AI, so I invite you to have a look over them, especially the most recent one. What I want to talk about next are the maps. So the big problem at hand is what to do about the 60,000 creatures and objects that need to be created and updated. Initially what I wanted to do was just kind of create everything at startup and always update everything during runtime, which actually works out in a release build, but not so much in a debug build, which was kind of proving problematic, so I didn't go in that direction, at least not entirely. So to back up a little bit, I'll start by explaining what Mangos did about this. So imagine you're looking down at the world from the top down, and then you divide everything up into a really big grid. Then imagine wherever the player is standing, things need to be updated and created accordingly around him. So you have your grid, we'll say max grid, and let's say we divided everything up into 64 by 64 squares. we'd want to do like container max grid, but I'll just be lazy and just say that we've got a list of objects, call it container, and then when a max grid, so we've got our X and our Y here. And that's the idea behind what Mangos did. Then every server tick for every player, they do something like, what they'll do is they'll say, you know, give me a list of all of the nodes around me, integer nodes rather. So you'd have like you tell it your position in the world, that'd be a float within the search radius or something like that. And then for each of those nodes, you pretty much just update everything inside that container, only unfortunately it's not written this elegantly. But they can't do that for every player, otherwise two guys standing on top of each other are going to have to, you know, they would end up updating all the same things twice. So what they do is they remember which containers have been updated, and they pretty much do it exactly like this, where they have, say, like a vector or list or something like that, an unordered map maybe, of just some Boolean values, and during the iteration, they'll say if it's been updated, then just move on, and then once it's been updated once, mark that it's been updated. Now, the problem I had with this is that I didn't necessarily like the idea of constantly deducing what needed to be updated. The way Mangos has set it up, it's not guaranteed that something that's been created is being updated, which I didn't like because I've seen cases where something may patrol out of range of any other player, and then it gets kind of stuck out there, and it's also technically more work to be making all of these computations. So what I did was I tied all of this in with where the objects are stored. The best way to store the objects is definitely an unordered map for each type of object, one for creatures, one for players, etc. And then what I do for updating is just kind of iterate through all of the objects in the container. The only difference being that the iterator may be invalidated during iteration, which is what the master iterator variable you see here is for. I also update the players separately above and load things around them if there's a need for it. This goes back to making sure that the program is runnable in a debug build. As far as loading goes, there's three things that can have permanency within the world: a creature, a game object, and a player's corpse. So when this function is called, it checks if there's data for making a creature, then a game object, and then a corpse. And inside each grid container here is a list of each WO that could have stuff telling us that it has permanent data, and more or less the computation for figuring out what grids to iterate through is what you might imagine. So this guarantees that anything that exists in the world is also being updated. And it's also a way to ensure that everything in an instance is both always created and always being updated, which is actually completely different in Mangos, where it creates and updates everything as if it were a regular outdoor map. And that, of course, can be problematic for a lot of things. For example, let's say if there's a patrol at the far end of a dungeon, and we want to give it a patrol that goes a very long distance, even if the players are still at the front portal, we need to make sure that that creature is always being updated. And the same goes for pretty much the whole dungeon. One last difference I'll mention is that I wanted a straightforward way to just ask the map for a list of objects within a certain radius of a position, which isn't really a big deal once you have the rest set up, but it definitely makes gameplay programming a lot easier, especially when working with spells. The last thing I'd like to talk about is spellcasting for creatures and how it ties in with the AI. So in Mangos, they actually have two separate functions for checking whether or not a creature can cast a spell, and they each check different things. But one of them is always checked no matter what, and the other necessarily is not. Likewise, the one that isn't always used isn't as comprehensive. So basically, it's like this, where you kind of have and that's the very comprehensive check, where everything that could stop a spell from being casted is checked. Then elsewhere, inside their AI class, they have when really there shouldn't even be a function like this. You want to avoid repeating your functionality. So the design I went with was kind of like this. And this way, I always know the result of trying to cast the spell, which enables me to do things a little different in the AI. So instead of a command being like this, I instead have something like this. And then instead of an event not happening but the timer moving on, it keeps trying to do it until it does, and then once it does it, it sets the timer. So these seem like small differences, but they actually have a big difference in delivering consistency. So this is already my longest video by no small amount. So on that note, I guess I'm going to go ahead and stop here. I'd like to, keep talking about more things regarding the software, but this being a 20-minute video, I'm going to have to cut it short. But if you have any specific questions regarding the design, feel free to ask me on our forums, make a post there or send a private message, and we'll try to get back to you as soon as we can. Anyway, thanks for watching and take care, guys.